2025 AMC 12B, question number 23. Let S be the set of all integers Z such that for all pairs of non-negative integer xy with the order x, y, z, x less than y less than z, the remainder when 2025x is divided by z is less than the remainder when 2025y is divided by z. What is the sum of all the elements of the set S? So we need some basic concepts we're going to review for that. The first one I'm going to talk about remainder. When any number is divided by 5, the remainder can only be the number less than 5, 0, 1, 2, 3, or 4. So when any number n divided by m, the remainder can only be 0 to m minus 1. That's a remainder basic concept. The next concept is that a sum of all positive factors. For the integer n with a prime factorization, n equal to p1 to the k1 power, p2 to the k2 power, blah, blah, blah. And then the sum of all possible positive factors will be in this form. For each of the product will be the sum all the factors power of p1 to the k1, including p1 to the k1 power itself. You add all these factors together. Same thing for other prime factors. For each of the prime factors, you add all their factors put into the sum, and then multiply by all these sum, you will get the sum of all possible positive factors for the integer n. Let's go back to the question itself. S is the integer n, any pair of the non-negative integer xy, and then for z, the pair of the value less than the z, 2025, the smaller number divided by the z is less than the remainder when 2025 times y divided by z. So this is less, the remainder will be less. So that's the pair of xy satisfy this condition. We want to find for such a z, and then we get a sum of all of them. So I'm going to let the rk denote the remainder when 2025k divided by z. So if it is x, that will be rx. If it is y, it will be 2025y divided by z for the remainder. This means when 2025k divided by z, the remainder is r of k. By given the condition, for any x and y, the pair less than z, the value is smaller, the remainder will be smaller. So rx less than ry. So in that case, we'll get any value less than z from 0 to z minus 1. And then you're going to get the remainder r0 all the way to rz minus 1 in this order. The smaller the k, the smaller the remainder for any z greater than 1. But when 2025x divided by z, the remainder can only be 0 to z minus 1 by the remainder property. So therefore, the r0 equal to 0, r1 equal to 1, rz minus 1 is equal to z minus 1. That has to be in that form. And also they're in this order, and I only have z remainders, including 0. And also they are in increasing order. So corresponding to that, r0 must be 0, r1 must be 1, all the way to rz minus 1 equal to z minus 1. So we just get this conclusion. So from here, basically Rk equal to K for any value of K less than Z. 2025K equivalent to K modular Z. Because from here, Rk equal to K, we're going to conclude 2025 times K divided by Z will be equal to K. Now it's a property. So this is what we get so far. 2025K divided by Z. The remainder is K. If you move the K over to the left-hand side, it will be 2024K is congruent to 0 modulo Z. K varies from 1 to Z minus 1 for the equation satisfy the condition. So the Z must be the factor of 2024 because this means Z is the factor of 2024K, but K is changing from 1 to 0, a Z minus 1. So therefore, the Z must be the factor of 2024. So the question becomes, the sum of all the possible value of a Z is the same as the sum of all possible positive factor of 2024 other than 1. Now let's find out the factor of 2024. We can prime factorize the 2024 as 2 to the third times 11 times 23. And then the sum of all the positive factors, as what we did, we get all the factor of each prime factorization. You add all the factors up, like 2 to the third, I'm going to add up from 1, 2 to the 0, 2 to the 1, 2 to the second, 2 to the third, all the factor of 2 to the third, adding up. For 11, that will be the factor will be 1 and 11 add up. For 23, the factor will be 1 and 23 add up. And you multiply these out, you will get, this is a 12 times 24, which is a 4,320. So that should be all the positive factor as the sum. But this is only including the factor 1. The requested number does not include 1. So the sum of all the qualified value of Z will be 4,320 minus 1, which is 4,319. So we get the answer, which is D, 4,319.